so I don't forget measurement units. Then I write, so the Ebbinghaus learning model asserts that P is given by, so P of T. So this is in percentage, okay? So it's Q plus 100 minus Q times e to negative kt. So they are giving us a formula where Q is the percentage that would that we never forget, okay? And K is a constant that depends on the knowledge learned. Suppose that Q, so they're giving us now 45 and 45, and K equals 0.5. So this is in percent, this is in percent, this is in percent. They're asking us to complete parts A through E. Okay, find the percentage retained after 0, 1, 2, 6, and 10. 0, 1, 2, 6, and 10. Complete the table to the right. Okay, fine. So let's stop sharing for a second. So how do I enter the function in the graphing calculator? As P of T equals 45 plus 100 minus 45, so that's 55, times e to negative 0.5t. And again, I'm going to write what they want. So 0, 1, 2, 6, and 10. Fine. So 0, 1, 2, 6, and 10. P of 0, P of 1, P of 2, P of 6, and P of 10. And yes, we can put them nicely in a table. Now I'm going to share my screen and put this in the graphing calculator. I'm not going to do this by hand. And I'm not going to do it separate, one by one. No. I'm going to put the function in as 45 plus 55, second and e. No, that's not what I meant. 45 plus 55 times e, right here. Yes. You know me, I love my parentheses. Again, it can work, but I don't know again what your calculator is, and it's easier for me to just stick with my step-by-step. Okay, so then I go to second and table, and I punch in 0, and then 1, and then 2, and then 6, and then 10. And then I go to the right column to make sure I get what I want. Although it's very clear already in here. I can round that up to 2 decimal digits. I don't have to go so scroll up and down. So I have 100%, which makes sense. And then 78.36, and then 65.23, and then 47.74, and then 45.37. And all these have to be percent. Remember the measurement unit. If it's abstract and there is no measurement unit, then we're off the hook. But if anything, I have weeks, percent, whatever, I have to write the measurement unit. So this was part A. Okay, let's see, where is the problem? Okay, how do I get to part, okay, where are you guys? I lost you. Okay, I don't know what's going to give me, so let's say, complete the table to the right. Percentage. Round to 1 decimal place. Ah, okay. I should have read that first. So I'm going to put in 100. I'm going to put in 78.4. I'm going to put in 65.2. I'm going to put in 47.7. And I'm going to put in 45.4 because they wanted 1 decimal. Okay. Moving on. Find the limit. Okay, great. So that's part B. So limit of P of T as T approaches infinity. Awesome. Okay. So this is very similar to something we did last time together. So I have to find what happens to p of t as t approaches infinity. I have to start here. So let me copy it. It's better. I don't have to go back up there. T approaches infinity. 45 plus 55 e to negative 0.5 t. So I have to start with t. So when t approaches infinity, negative 0.5 t will go where? What is the tendency of this when t approaches infinity?
Is it 0?
Careful. Negative 0.5 times infinity. What will this go? Say it again.
Negative?
Negative what?
Infinity.
Negative infinity. Perfect. Stay with me. Okay. Now I want e to negative infinity. We have this in our notes last time. E to negative infinity will approach
Zero.
yes, of course, because this is 1 over e to infinity. E to infinity is so big that when I divide 1 by it, it will definitely approach 0. So now I know that this approaches 0. How much is 55 times 0?
0.
Perfect. How much is 0 plus 45?
45.
45. We're going to study this in this chapter coming up, chapter 3. When t approaches infinity, if the limit is a number, remember we said 45 is the horizontal asymptote at infinity. Okay, so back to sharing here. I have to, oh, what is going on? I have to enter 45. Then we'll continue.
I have a question about that, actually.
Yes, yes.
So last class you showed us with the equation in y equals that you could just plug in like big numbers.
Yes. Yes.
Is that every
Yes, if it says approaches infinity, that's all we need to do. That's what we did. So we have the function here. So we go to second and table and make sure you are in x. So let's say a large x. Well, 50 is not a large x. 45, but 500 is a large x. And 4,000 or 4 million, it's a large x. So as x increases without bound, we say, the function approaches what? What does it approach?
$45.
45. That's it. And this is what we got step by step. This approaches negative infinity. E to negative infinity is 0. 0 times 55 is 0. Limit of 45 is 45. We had a similar problem last time. Is this okay? I'm not sure, did I answer your question or not?
I did. Thank you.
Yes, okay, perfect, thank you. Okay, where am I? Here. Now it says sketch the graph. Choose the correct graph below. Okay, well, we can, so as we see, one option here would be to just look at the fact that x, this is very important, x is between 0 and 10, and y is between 0 and 100. And we know that this function, we haven't talked about it in detail, this is in chapter 3, but we know that this function has a horizontal asymptote at 45. Maximum. It cannot be above. It's not possible. If, see, as x approaches infinity, the value of the function gets closer and closer to 45. This is not possible. Right? As we increase, for it to go to increase, increase, increase. Okay? So this is a possibility because I see there is a horizontal asymptote of 45. This is absolutely impossible because the horizontal asymptote here is 0. This is another possibility. So as long as it has a, even this one, sorry, even this one, but I'm sorry, no, this one doesn't have at infinity, right? So it has to be at infinity. So this is not an option. This is not an option. So these are possible. Okay? Now, why is this not possible? Because look at what we just observed. At 0 is 100%. At 1 decreases to this. At 2 decreases to this. At 6 decreases to this. At 10 decreases to this, and eventually gets to 45. So we really don't have to graph it. We will graph it. But we don't have to graph it because it starts at 100. When x is 0, y is 100. This is not the case. This is not the case. This is at 60 or 50. I don't even see what it is. And so on and so forth. Not possible, not possible, not possible. And it comes from 100 closer and closer to 45. So now in order to convince ourselves that that's the case, we are going to mimic exactly what they wanted. We are going to put the x between 0 and 10. We are with a scale of 1, that's okay. We're going to put the y between 0 and 100 with a scale of 20. And now I'm going to click enter. And to be exact, I will also graph, we're going to do that in chapter 3, I will also graph this line, y equals 45. And now I'll click on graph. Aha! And now the red line, which is the horizontal asymptote. So it's coming from 100, closer, decreasing, 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 eventually getting closer and closer to 45. That's the reason why we always put the horizontal asymptote as a different or a separate function or additional function. So this is what I had. And in the window, exactly what I saw there. All those 4 graphs show between this and this. And obviously it makes sense because we needed to see from 100 down to 0, of course. Percent cannot be more than 100 or less than 0. Okay, so we're back to the problem. I think there was, so obviously we're going to choose B. No question about that. And let's see. Find the rate of change of P with respect to time. So what are we asked to find here? It's very clear. It's the derivative. So let's find the derivative. See, that's the reason why I kindly ask you to stay on track and do this problem so we can analyze, because if you haven't seen this problem, then it's more difficult, right? I hope that you all looked at it before. Okay, so in part C, they want us to find P prime of t. So I looked carefully. I don't see any product. I don't see any quotient. I see a number, which the derivative will be 0. I see another number times an exponential function. Not difficult. So this is 0, so I copy 55. And how do I differentiate e to a function? E to a function prime. What is the rule for that? Anyone?
I'm not sure if I remember this correctly, but is it E, F, and then times F prime?
Always. It's e to the, so this is the easiest function to remember, right? Because e prime, e to the x prime is e to the x. And I should say, to be exact, times the inner function prime. But I don't. There is no need because this is, as we know, 1. Excellent. This is indeed the rule. So I have to copy e to negative 0.5t times, can anyone give us the inner function prime? This piece. What is the inner function prime?
-0.5.
Excellent, thank you. Good. So now, of course, I have to multiply these two. And 2, 7, and 1 decimal with minus in front, e to negative 0.5t. So I have to enter negative 27.5 times e to negative 0.5t. I'm checking my numbers, yep. So, help, how do I enter this? So 27.5. And how do I enter e here? Help me. No, that's not it.
I think you just type in E.
Oh, I type in e?
Yeah.
Okay. And then this appears with the power. Okay, thank you. Do I need parentheses?
No.
0.5. And it was t and close.
And
Will
it was negative.
Yes, I put the negative.
No, negative 27.5.
Okay, yeah. Thank you. So I don't know, as you can tell, I've never done this. I didn't have to enter negative 0.5 and t. Is everything okay? It will scream at me.
Put two.
So I don't need to enter the parentheses, or
The parentheses are fine. You put 2 points before the 5,
oh,
and then it should be good now.
okay, let me put the 0 just in case. Okay, now it's okay. Yay! Good, thank you. Good. So there is one more part. Interpret the meaning of the derivative. Choose the correct answer below. Perfect. So the derivative represents the amount of knowledge. Really? No way. The derivative is the ratio at which exactly 10% of knowledge is lost. Really? The derivative is the rate at which the retained knowledge changes per week. The derivative is the amount of time. Really? It takes to lose all. Okay, so which one?
C.
Of course. The derivative does not represent an amount of knowledge. No, it's a rate of change. The derivative is the rate at which no, this is just made up. The derivative is the amount of time it takes. No. The derivative is the rate at which the retained knowledge, which is P, changes per week. So it has to be percent per week. Excellent. Well done. Good. Any questions on this problem or anything else that you may have questions on? Anything? It was a very good experiment here. A very good question.
I actually have another question, not
Yes.
for this.
Yes.
That. It's find the equation of the line tangent to a graph.
Yes, I'm ready. Any problem?
F of x equals ln x to the 5th, and then x equals 9.
This?
Yes.
Good. So we want to find the equation of the tangent line to the graph of this at the point with x equals 9. Am I correct?
Yes.
Perfect. First of all, once I have x, I have to determine y. I do not have the point yet. So I can leave it just plugged in as natural log 9 to the 5th power. Or you can write it as 5 natural log 9. So that the point is 9, 5 natural log 9. So I have my point. Then I know that the equation, let me move this page away. The equation will be y minus y1 equals the slope times x minus x1. My x1 is 9. The y1 is definitely 5, the natural log 9. I need, once I get this piece, then I'm in business. But how do I get this piece? Can anyone help? What should I determine first?